This is Parth here. I'll be walking you through EvaLine. EvaLine is a cancer query assistant bot, which is going to help you to walk you through your diagnosis, through your treatment, and also probably help in research. If you're a caregiver and you would like to understand more about how the treatment works. Now, EvaLine is going to query through a set of internationally recommended documents from organizations like NCCN, ESMO, and ASCO and provide you relevant information. Currently, we have two modules. One is the patient and caregiver as well as the professional. So the professional module is for professionals like doctors, nurses, where it can help them solve their queries, but it's currently in development. But patient and caregiver is fully functional. And when it comes to this, we have provided a short description of what all you can do. So let me quickly walk you through it. The settings is going to help you select the language. Currently, we are supporting English, Hindi, Kannada, Tamil, and Telugu. We are also focusing on different LLMs. We have two as of now. We can pick either of them. Now, when it comes to search mode, we have got naive, local, global, hybrid, and no RAG. No RAG would just be a normal GPT based, LLM based response. Now, when it comes to hybrid mode, we are I mean, let me start from the top. We are looking at naive. Naive is a mode where you're trying to focus through the entire document. You're trying to pick out things which may be relevant, but this is not going to do it across multiple documents. It will just be at the same document, at the same small library. When you have local mode is going to look through specifics of a certain document. We don't have to specify what document. Based on the question, it is smart enough to figure out what part of the document to look through. Global mode is going to look through the entire document and provide you with an answer. Hybrid is going to make use of both local and hybrid search methods, which takes time and it provides you with a result. Now, with all this information here, we can quickly apply the settings. Bloody hell. So yeah, so once we apply the settings, we can it's going to start answering your queries. So you can ask general questions like, pardon me. Yeah, you can ask general questions to the LLM model. Let's go with no rack, considering we don't have all the resources to run this entirely, and we can have a quick conversation. And it takes a while to reply, always. But yeah, I mean, considering this is running locally, considering this is not running on any huge GPU, it's running on all local resources, so it is performing exceptionally well. Now, it goes through a set of network. Before that, let me just walk you through the methodology of Evelyn. What the model does, what the LLM based module does, is it is going to, when you ask a question, normal LLM response would be the question goes to the LLM and you get the answer. So you have your step 5 and then step 9, and that's what you get. So you're missing the steps 1 to 5 and you're missing the steps from 5 to 9 as well. So in order to add little more complexity, because doctors often face trouble because the patients are suffering from something called as an idiot syndrome. Idiot syndrome would very in a very general it's an acronym for internet derived information obstructing treatment. We don't want patients to sort of go through Google, go through internet, and go through some unreliable sources, like for example you have your WhatsApp University, and come up with a response which is not going to trouble you. So not going to actually help and hamper the course of the treatment as well. So this is something that we are trying to tackle. This is something that we are trying to do by providing a list of documents. So you can think of this as a list, library, which is which is having a lot of documents from multiple sources, and it is stored in something called as a graph database. So you have your entities, you have your relationships, you have your vectors with a lot of information. You can just think of this as a library. Now, whenever a question is asked, the query passes through the same model which has converted the PDFs or document format into this graph format, because it passes through the same thing, so that your query is also broken down in the same format, and it starts scanning and it picks out the best available match. So here we are trying to do something called as a nearest neighbor search, which is a type of unsupervised machine learning model. And when it searches through it, and it goes rolls back to the prompt, where in the prompt we have provided specific way of how it addresses the text, for it to be concise, for it to be free of medical jargon, for it to be empathetic towards the patient, and then it goes to the LLM. Now LLM is smart. LLMs are good at conversation. We make LLMs write our emails. We use ChatGPT to write our emails. So yeah, this is just rolling it back to the user with a more much clear answer. So that is how EvaLine works, and that is how we have made the model work. Now with this information, once we go back once we go back to the graph relationships, in fact, so this is the entire network. Whatever information we provided, it has made a network out of it. So when we see like certain things like here, for example, this node, we cannot see the relationships as of now, but these are all quite self-explanatory, because you have thoracic radiology, you have radiation oncology, you have these are all your healthcare providers. These are technically your secondary healthcare providers, and you have radiation oncology, which is your tertiary healthcare provider. And with all this, the idea is that you detect the things early. For example, here you are having this drug which is probably you resistant or sensitive to this mutation, and that's just is just the idea of how it works. And yes, guys, that's about it. Our code is currently available on GitHub, open for public use. Our future direction would be trying to scale this up to an extent where we include all sorts of cancers, because especially in a country like India, where there are only 67 regional cancer centers, it becomes very difficult for patients to communicate with the right doctors, with the right tertiary treatment centers. So that becomes a problem, and hence we are trying to tackle that situation. And another future direction that we would like to go in is that if we could help provide patients with psychological help, which we could provide patients with not psychological support rather, but yeah, the different things we could integrate. And another thing that we can do is that this framework could be implemented at a commercial scale, at an enterprise scale, where you have the data which is secure because it runs locally, you have no connection to the internet, and it provides you with a good answer. In fact, when it comes to this particular scenario, you do not want to give out a lot of patient information, risk giving out your information to get your query answered. So here, since it runs locally, in fact, this can be, if this is running on a big server, it will still not be connected to the internet. So there are very less chances of data leaks there, because there's only one way. When it's queried through a bot, it's only one way where the data is flowing. There is no other way to access the information. So that's the idea of us developing this. And yes, that's about it. Thank you for making it this far. If you have any queries, on our link tree, we have provided our LinkedIn, we have provided our GitHub source code as well. Do feel free to connect to us. Thank you.